All right, so I'm going to be going over the logarithm test review here. So for our first two questions, we have exponential equations. With exponential equations, the first thing you want to do is have the same base. So you're going to be looking at the bases, and the base is the number that carries an exponent. So if you have the same bases, you can immediately solve. You just set the exponents equal to each other and then solve for the variable. However, if you do not have the same bases, you're going to look at your larger number and see if you can, or your larger base, and see if you can change it to match the smaller number or smaller base using the exponent rules. And the only exponent rule you have to know for this is the power rule of exponents. Next, if you can't get the larger number to match the smaller number, which is what we're going to see in number 2, then you're going to have to change both bases so that you can have a common base. Then numbers 3 to 6 are examples where you cannot get a common base, so you're going to have to use logarithms to solve those. So we're going to start with number 1 first. And with number 1, we already have the same base, right? So our bases are 3. So we have the same base, so that means that we can just set the exponents equal to each other. So we're going to set both of the exponents equal to each other, and then we're just going to solve for x. So I have negative x plus 3 is equal to negative 2x. So now to solve for x, I'm going to combine like terms, right? So I want to get this negative x out of here and to the other side. So to get rid of it, I'm going to add x to both sides. It gets rid of this here. And then I'm left with 3 is equal to, now negative 2x plus x is just negative x, right? Now I want my variable to be positive, so I'm going to divide both sides by negative 1 so that the signs can change. So then I have negative 3 is equal to x. And that is my answer for number 1, answer B. For number 2, we don't have the same base, right? So we would want to see if we can change 216 to have a base of 36. Well, you would start with 36 squared, but 36 squared is over 1,000, so that's not going to work. So that means that we can't change the larger number to match the base of the smaller number. So what we have to do is we have to find a common base that both of these numbers share. So then we'll have to change both terms to have that same base. So we can look at the smaller number, and 36, that's actually a perfect square, right? So we know that we can change 36 to 6 squared. So now let's see if we can change 216 to have a base of 6. So if you don't know how to do this, you can just go to your calculator and you do, so 6 times 6, that's the same as 6 squared, right? That's 36. So let's try 6 times 6 times 6. Well, that gives us 216, and that's 6 cubed, right? So we can change both of these to have a common base of 6, right? So 216, I'm changing that to 6 cubed, right? And can't forget about this exponent, right? Because that doesn't go away. It stays there. So it's still going to be in... This 6 to the third power is the same as 216. So then we have to write an exponent of negative 3r on that. Next we have an equals. Next we have 36. And we're changing that to 6 squared, right? But it still carries that exponent of 2r. So I'm going to apply that exponent right here. Now this is where we use the power rule of exponents. And the power rule of exponents tells us that if we have a number or a variable or a term, so our base raised to an exponent, and then all that gets raised to an exponent as well, then we have to multiply the exponents together to simplify, right? So that means that we're going to multiply these two exponents together to simplify. So our equation becomes 6, and we're going to do 3 times negative 3r. That's negative 9r. So that's our new simplified exponent, is equal to 6. And we're going to do 2 times 2r. And 2 times 2r is 4r. So this is going to be 6 raised to the power 4r. So now that our exponents are simplified and our bases are the same, we can go ahead and solve, right? So now that we have the same bases, we're going to set both of the exponents equal to each other and solve for r. So I have negative 9r is equal to 4r. So from here, what we're going to do is we're going to solve for r. Now, this looks a little strange because there's no constants, right? There's no plus or minus, just a number with no variable. But we're going to do this, we're going to follow the same steps that we always follow, and that's going to be to condense our variables to just one variable, and, you know, so the way we're going to do that is first we're going to add 9r to both sides, right, to get rid of this, so plus 9r. Now, negative 9r plus 9r is 0, right? So we have 0 is equal to 4r plus 9r, which is 13r. So now again, we're solving for r, so we have to get rid of this 13 right here, and we're going to do that by dividing both sides by 13. 0 divided by 13, or 0 divided by any number, is always going to be 0. So we get 0 is equal to r. So now that means our answer is C, which is 0.